My name is Skylar Ham, and this is my poster comparing salinity levels, pH levels, and the clarity of the tributaries of the Great Miami River. My objective was to find different levels in the pH and the salinity, along with the clarity of these tributaries and the Great Miami River, to see how high or low they were, because this greatly affects how wildlife exists in these rivers and creeks. I hypothesized that the Great Miami River would have a higher salinity and pH rating and a lower clarity due to it being fed by all these different tributary creeks. Below here is a Google Earth image of all the areas that I got samples from, as well as the Great Miami River running through all of them. My field observations. All the tributaries pass through land zoned for agriculture. There were a lot of farms around where I was looking over here. They were flowing relatively the same, at the same speed. They were all pretty much the same sizes, excluding the Great Miami River, which was, of course, bigger, though Twin Creek was a bit smaller than the rest of the creeks. And some of these tributaries pass through towns as well. Along with this, I used plastic soda bottles that I washed out 3 times to collect the samples. Here you can see a picture of the Great Miami River, where I got my samples from, and you can see it runs through Hamilton. The pH methods and results. For this part of the experiment, I used a pH meter to gauge the levels of the pH. I first used the pH powders in regular water to ground the device so that I could use it as a base. And I measured all the water samples along with the distilled water as a control. Still water in Twin Creek had the highest acidity, whereas the Great Miami had only a pH of 6.7, which I did not expect, especially in a town. Then I measured the salinity, which for this I used another meter to measure the salinity in parts per million. Most of the creeks were exactly the same, Twin Creek being the highest out of all of them, but the Great Miami River did not have the highest. It had a higher salt content, but not really notable. For the clarity, all of them were pretty much the same in clarity, pretty clear, but there were small bits of sediment in each floating around, and Twin Creek, along with Mad River, had more sediment in it than the other samples. Why do you think the samples had a similar pH and salinity levels? Do you think it could be because of where they were located around farm areas? Could the surrounding farms be the culprit for these different higher or lower salinities due to the runoff from the different farms? And how do you think that will affect the wildlife that's living there? In conclusion, these different creeks and rivers had varying pH levels, some higher or lower than others, but still within the same range. Salinity followed the same pattern, being slightly higher than the national average. I conclude that the Great Miami River did not, in fact, have a higher salinity or pH level. It was similar to every other tributary, and it was not due to all of the other rivers and creeks combined into it did not add to the salinity and pH of the Great Miami River. I would like to thank Professor Miggendry for all the help with the research that was conducted and all of the more resources that I got from her. Thank you.